Alright, this video is going to be a little quick, kind of miscellaneous lesson over hopefully some review from pre-cal talking about a function that could potentially be even or a function that could potentially be odd, and then how the potential integrals for those even and odd functions can be pretty easy questions. So let's go through. We'll do this pretty quickly. Remember from pre-cal, a function is even if it's symmetric about the y-axis. That means the left side and the right side, they're going to match. So something like your typical y equals x squared parabola, that would be a good example of an even function. And so what we would look at is, hey, okay, if I had some integral and it was from negative a to a, that could be negative 5 to 5, or that could be negative 17 to 17. But if I had the same number on both sides, but of course the left one was negative, and if I was trying to get the area bounded by the function and the x-axis, well, since the function's even, I kind of can do a little bit of a shortcut. I know, hey, this left side, that left area, it's going to be the exact same as the, sorry, that was the right area is going to be the same as the left area. Since this graph is symmetric, those two regions are going to be the exact same size. So if you want this kind of cumulative area, if you want all the area from negative a to a, all of that region, what you could do is just take one of the sides. So I could just take the integral from 0 to a. So I could just take this area. And of course, you'd have f of x dx. If I found that area, which is just this right region, I could just double it. And why would you do that? Well, because instead of having to plug in the negative a, you could plug in a 0, and then you could just times 2. And plugging in 0 is really easy. Right? So when you're thinking about this even function, we know the area on the left, the area from negative a to a, that's going to be the same thing as the area on the right, the integration from 0 to a. Right? The left side and the right side, they're going to match. The area on the left equals the area on the right. So that means if you want that total area for the whole entire region, you could find the area on the left. So you could do negative a to 0 and then double it. But you could do 2 times the area on the left, or you could do 2 times the area on the right. Typically, this is what I would do. I would use the area on the right, because in the lower one's 0, then the upper one's a positive number. If you do this, then the lower one is a negative number. The upper one's 0. It's just a little bit easier to plug in the positive number in 0 than it is to plug in the negative number in 0. But the idea is, if it's even, then you could split it up. The left side and the right side, they match. So if you find the value of one of the sides, or if you know the value of one of the sides, you can just double it to get the total. All right, so let's look at a couple of examples underneath it. It says, given some even function, and it says the integration from 0 to 5. So that's basically the right side of the function. That area is going to be 3. Okay, so I know the area on the right is 3. Then here it says, what's the area from negative 5 to 5? Well, I know if the area on the right is 3, let's go do the part B first. Then the area on the left is going to also be 3, right? If this region is 5, then that region is also 5, or 3. I don't know why I keep getting the 5s in my head. Oh my gosh, because of those. If the area on the right from 0 to 5, if that area is 3, then we also know the area on the left from negative 5 to 0 must also be 3, right? If this region's 3, the other region's 3. So then the total from negative 5 to 5, the total, well, that's 3 and that's 3, the total would be 2 times 3, which would be 6. So then that region in sum, both the left side and the right side combined, would be an area worth of 6 units. Okay, and then if you did 4 times the total, again, negative 5 to 5, that's all the way across. 4 times the total, 4 times 6, that's 24. So those are pretty easy, right? If the function's even, the left side and the right side match. So if you know one of the sides, the other side's the same. And then if you want the total, you can just double one of the sides. Now, as easy as even functions are, the odd functions, I think, are even easier, because an odd function would look something similar to this, like a x to the third power, where you could have this area up above on the right side. But since you have an odd function, really this graph is going to be symmetrical about the origin. So one of the regions will be above, and then the other region will be below. So they're the same size, right? If this is an area of 5, that would be an area of 5. Or if that was an area of 7, this would be an area of 7. But one of them is above the x-axis, and the other is below the x-axis. right? So here, negative a to a, or negative a to 0, it would be the negative version of the integration from 0 to a. Now that would work even if this graph was the kind of the opposite. If the left side was up above and the right side was down below, this would still work, right? One of them will be positive, the other one would be negative. So if I wanted this kind of cumulative area all the way from negative a to a, since these regions are the exact same size, but one's above, one's below, those are going to cancel. And then that kind of cumulative area from negative a to a is going to end up being 0. Okay, so even functions, nice. Find one side, double it. That gets you the total. Odd functions are even easier because the two sides perfectly cancel out. They're the same size, but one's positive, one's negative. All right, a couple of examples, then we're done with this quick video. Given the function's odd, so it looks something more or less like this, and it says the area on the right from 0 to 5, that area on the right is 3. Then it says find the total from negative 5 to 5. I think it's easier to find the left side. I should always, every year I think about switching these, and then every year I just don't. If you know the right side, then the left side is just the negative version of it, which means the total would be 0 because they cancel out, and then 4 times the total, right? Negative 5 to 5 is the total. 4 times the total is 0. Okay, so odd functions means symmetrical about the origin, which means the left side and the right side, they're going to match, but one's above, one's below. It doesn't have to be that the left side's the negative and the right side's the positive. That's just the example I drew. You could have just as easily had something like this, and then that relationship would still be the same. From negative a to a, they would cancel out because they're the same regions, but one's above, one's below. All right, so that's even and odd. A little quick recap. We'll do a little bit more with even and odd later on in the year. But when we're talking about area, if the fact that a function is even or odd happens to come up, that actually is a little bit of a shortcut and makes these integral questions pretty quick and pretty easy.